You run into some interesting thinking about equipment process as you work. And as you know, we've gotten back into the sulfur industry thanks to Maheen and some others, and we're doing quite well with that. We were big in sulfur back in the 80s, and we kind of took a hiatus from that during the 90s, and we're coming back again. And back in the 80s, we'd be doing plants, 100 ton a day, 50 ton a day, 200 ton a day sulfur plants. And we're doing well with that, but the business development people, they wanted to try to come up with, other markets. And so they were able to come up with a concept and a niche market that seemed like it had a requirement to be filled, and they came up with this sulfur system on a skid concept. And what that would be is a half a ton a day plant, relatively small, but it would use the same proven process as the 50 ton per day plants. So you'd have 1/100th the flow rate, but the same chemistry required. And it sounded like a pretty decent idea. Then they were able to find a client that said, yeah, that sounds like I could use that. I'll be the guinea pig for you. So we ran into a couple of interesting thoughts that didn't turn out quite so well on that job. First of all, plant 1/100th the size does not cost 1/100th of the amount. Part of the problem was that they were comparing the cost to a well-developed, a well-defined, mature product line. All the development work's been done. You know exactly what to do. You don't have any redesign work on it. And we were trying to do basically a development project on a brand new concept. So the cost didn't come out quite the way they had expected. Fallacy number 2, the same equipment can be used for the much smaller plant, and that's not the case at all. Number 3, the same P&IDs can be used. Well, if you can't use the same equipment, you probably can't use the same P&IDs, so brand new P&IDs had to be generated for the entire system. And number 4, the same control system can be used. Well, again, if you can't use the same equipment, you can't use the same control scheme. The problem is that a pump size for 500 GPM and 600 foot ahead for the 50 ton per day plant was now sized for 5 GPM, but it had the same 600 foot ahead requirement. So a centrifugal will do this without too much trouble at all. There's no way a centrifugal pump can do that. The flow is much too small. So we had to go from a centrifugal to a gear type. Positive displacement instead of a dynamic machine. Also, because it's a gear type, there had to be some level of lubricity in the fluid for it to last for any length of time, and unfortunately the fluid we had didn't have any lubricity in it. So we knew that it was going to be a maintenance problem. Every couple of years it was going to have to be taken out and be replaced. It certainly cost more than 1/100th of the original centrifugal price because of the economy of scale. Centrifugal pumps are fairly inexpensive. There's very minor critical machining and close tolerances to be held, whereas on a gear type, for it to operate, every fit's a precision fit. So the pumpage was a hydrocarbon with very little lubricity, but the footprint was acceptable. It fit on that skid very nicely, so at least it had one thing going for it. Because it was a positive displacement pump, the control valves, which had been used to control a process previously, could not be used. PD pump, it'll put out whatever pressure it needs to push the fluid forward at whatever design rate the pump was set at. And if you have control valves trying to stop it, it'll just put out more pressure. So we had to do control either by recycling or by speed variation, and we ended up picking speed variation. So it was one of the first VFD applications that we started to use. So the plant was built and it was installed, and it did fit on a skid. It was a big skid, but it did fit on a skid. And we got it up and running. Okay, but the use of the speed controller pump never seemed to just quite work properly. Trying to interface it with one of the early PLCs so that it could match the process conditions to speed never seemed to work as well as you would have expected it to. And so the operators were constantly having to go out and tweak the speed up and tweak the speed down to try to get it to match the process. And so, of course, the client was not real comfortable with this gear type pump, and I couldn't blame them, but we just didn't have any alternatives. And that's when we found out fallacy number 5, the client uses the same specifications that he has us use. So what happened, the client used the plant for a couple of months, and he decided that he had to make some changes to it just to make it so that it operated better. And we heard about these a couple of months after the client was done with them. And so that pump that we had, the client went out to an equipment supply house nearby, and he actually found a small centrifugal pump that was going to work. And so they scrapped this PD pump, the gear type pump, and the control system that we had, and he bought this centrifugal pump. He was real happy with it because it was a non-metallic pump, so it was really inexpensive. He was real pleased with that. And it fit the footprint really well, and so he was able to get his control valve into the discharge of that pump and use the control valve for process control like the big 50-ton-a-day plants normally would. So he was very pleased once he made that change. And he came back and he told our project staff that he'd had to make these changes, but once he had done that the plant seemed to be operating reasonably well. And so what I eventually had heard about the changes that they made, and they'd use this non-metallic pump. And so, of course, the project guys come over and said, why didn't we use that pump? So we had to explain to them that we have client specifications that we had to meet which don't allow non-metallic pumps. And the reason is that provided, should there ever be an accident, there'd be a fire on that skid, that non-metallic pump is going to melt. And all the hydrocarbon that's flowing into it will now be flowing into a raging fire, which will then just burn even hotter. So we always, have to buy the materials that we have to use for our hydrocarbon services are always steel or cast iron, some metallic which can't burn or can't melt, so that we maintain control over the process fluids that we're trying to keep from getting out and burning and exploding. So those are a couple of things that we learned on that project. I don't think we ever did a second one, and we kind of got out of the sulfur business soon thereafter. But once we explained this to our project staff that there's a significant safety issue with that, they went back to the client and said that we do have this concern. You may want to reconsider the pump selection that you have made, just to try to keep from having an accident made worse. So it's not unusual. We run into that problem all the time. And it's on the CNRL job, we had to buy some standby generators. And they gave us the list of the 3 vendors that they always went to. And they said, we get good service from these guys, we get good pricing, these guys are top-notch, we love them, pick one of those, you'll do fine. And so we gathered up all the CNRL specifications, we put a requisition together, and we sent it out to the vendors. The vendors said, we're not going to quote this. What do you mean you're not going to? We're not going to bother reading all these specifications. We've never seen these before. Well, you sold to CNRL. Oh, yeah, we've sold a dozen machines to CNRL. You've never seen these specs? No. The guys that we deal with, they call us up. They tell us they want a 50 megawatt machine or 50 kilowatt machine. And we tell them how much it's going to be. And they say, okay, great, we'll cut you a PO today. It's built to whatever standards we happen to apply at the time, and we ship it out, they install it, they run it. Same thing with some of the ConocoPhillips jobs. The guys who are maintaining equipment, the guys who are in operations, the engineering staff's in Anchorage. We're up here in Prudhoe Bay. We have to keep the equipment running, which means we can't wait for major projects people to come in and put together all these specifications. We need the equipment now. We're going to talk to someone we know that can supply it to us. It may not meet our specs, but it'll certainly be fit for service, and that's what we're going to get. And so it's not that uncommon. And sometimes the operations guys come up to say, now why is this piece of equipment costing so much and taking so long to get? We ordered something similar at the same time. It was a third the money, and we already have it. That's because we have to comply with their requirements, because we're contracted to them, and their own internal people don't necessarily have to do so.
And that's exactly what I don't understand. Why, since we don't do the operations, why do we do the procurement? Why do we buy the equipment when we don't actually install it?
One reason that the oil companies come to us, our clients come to us, is because they want to have the proper traceability. They want to make sure that the proper equipment meeting their engineering specifications is being bought. You know, for small pieces of equipment, they'll go ahead and let the operations guys get away with it. But when you talk about major pieces of the equipment, they want to make sure it meets their engineering requirements. So that's why they come to us. They recognize they're paying more for the same equipment because we ask for drawings. We do an evaluation to make sure it's going to operate properly. And we do that to make sure that the client doesn't hurt themselves or put themselves in a situation where the equipment they get is wrong or causes other problems upstream or downstream of the system. There have been a lot of times when the operators have just said, I want to increase the flow rate on this, so I'm going to just make this little change here. And it causes problems downstream because the downstream equipment wasn't sized properly for the new flow rates. So we do a more in-depth analysis than their operators will do, and so we can see what the ramifications of changes are. So, okay, guys, I want to thank you all for being a very nice audience and being so nice to me.